Hi and I welcome everyone to my channel. Today we are going to see the topic quadrilaterals. So what does mean by a quadrilateral? So the question is you want to just understand that what is mean by a quadrilateral. Any closed polygon with four angles, four vertex and four sides is known as the quadrilateral. It could be regular or irregular. Okay, the shape could be regular or irregular, and the sum of a quadrilateral is 316 degree. We know in the previous chapter you learned that the sum of a triangle is 180 degree, and now we learned that the sum of a quadrilateral is 316 degree. So in the exam you may get confused if they ask the question like this. I mean, prove that it is a quadrilateral. So they can ask like this. So I will teach you that how we should do this. It is very simple. They ask that prove that it is a quadrilateral. How do you know it is a quadrilateral? They ask like that. Okay. So first we just want to take as the numbers 1, 2, 3 and 4, 5, 6. So I take like this. So this two is like triangles, right? So ABC is like a triangle and ADC is like a triangle. So we can take like that, right? So in a triangle ABC, I mean the angles 1, 3 and 4, okay, is equal to 180 degree. And the second triangle is in triangle ADC is equal to 2 angle 2 angle 5 angle 6 is equal to 180 degree. I mean, when you add these angles, then you will get 180 degree. Okay, so our plus symbol should be then you can. Okay, now it is correct. So if you add these angles, these two angles, you will get 316 degree. So just angle 1, angle 3 plus angle 3, angle 4, and angle 2 plus angle 5 plus angle 6 is equal to 316 degree. Because when you add 180 degree plus 180 degree, the result will be the 316 degree, and we already know that the sum of a quadrilateral is 316 degree. So we can simply prove that it is a quadrilateral. So now we can go that what are the types of quadrilateral are there. Okay, first one is trapezium. You have learned about trapezium in your lower classes. So trapezium, one pair of opposite sides will be the parallel, will be parallel. So EF and GH is parallel. So the lines I put mention that parallel lines. Okay, then next, parallelogram. In parallelogram, both pairs of opposite sides are parallel. A, B, C, D are parallel, and A, C, and B, D are parallel. Though we can now go to the next polygon, next quadrilateral. The next quadrilateral is rectangle. So the rectangle should be, all four angles should be 19 degree. Okay, all the four angles are 19 degree and the opposite sides are equal. In this triangle picture, these opposite sides are equal. Okay, then next, both the pair of opposite sides is parallel. I mean the pair of opposite sides is parallel. These two are parallel and these two are parallel. Next one is square. Okay, in square the all four angles are equal. I mean these four angles are equal and opposite sides are parallel. And the same as I said in the rectangle have I mean the four angles are 19 degree. Has same the square also, the four angles are 19 degree. Next one is rhombus. Okay, in rhombus all four sides are equal and opposite sides are parallel and opposite angles are equal. So here you have to notice that opposite angles are equal. So here these two angles are equal and these two angles are equal. Then next, diagonals intersect each other at center and at 19 degree. 19 degree which means right angle. Then next, kite, one of our favorite shape. We have been studying this shape from our childhood. Okay, so it is a very favorite of everyone, right? Then two pairs of adjacent sides are equal here. Okay, these two pair of adjacent sides are equal. So we have already seen the types of coordinators. So now the theorem we are going to see 8.1. A diagonal of a parallelogram divides it into two congruent triangles. So this is the parallelogram shape, and when a diagonal we draw here, it divides into two congruent triangles. The next, theorem 8.2, in a parallelogram opposite sides are equal. Okay, so in a parallelogram the opposite sides will be always equal. The next, if each pair of opposite sides of a quadrilateral is equal, then it is a parallelogram. So they are saying, first we already saw that what is meant by a quadrilateral. So, okay, any closed polygon that has four vertex, four angles and four sides is called as the quadrilateral. We already know that. So here they have said that if each pair of opposite sides of a quadrilateral is equal, so the opposite sides of a quadrilateral is equal, then it is called as parallelogram. If these two sides and these two sides are equal, then it is called as parallelogram. The next theorem, here the same one is repeated here. If in a parallelogram each pair of opposite angles is equal, then it is a parallelogram. The same thing had been mentioned another time. So next one, the diagonals of a parallelogram bisect each other. Okay, in a parallelogram the diagonals will intersect each other. Then the next theorem is, if the diagonals of a the quadrilateral should come. If the diagonals of a quadrilateral bisect each other, then it is a parallelogram. A quadrilateral is a parallelogram if a pair of opposite sides is equal and parallel. Okay, so here this is a quadrilateral, and the quadrilateral is said to be parallelogram when its pair of opposite sides is equal and also parallel. Okay, so just a simple one. The next one, midpoint theorem. It looks tough, but it is very simple. Okay, the line segment. So what is mean by the line segment? So we have already studied in chapter 6 that line segment means a line with two endpoint is known as the line segment. You already know that, right? So the line segment joining midpoints. So the midpoint of a triangle is D and E. So joining midpoints of two sides of a triangle is parallel to the third side of the triangle and is off of it. Very simple concept. Let me draw this triangle again so you can understand better. Okay. So the triangle. So they have given the line segment joining midpoints of two sides. These two sides. So midpoint is this, right? So this. So we have to give the name for this A, B, C, and here I have given D and E. So D and E is the line segment here. Okay. So here the point should be clear. Okay, because we know that the line segment means it should have two endpoints. Okay, so midpoints of two sides of a triangle is parallel to the third side of the triangle and is off of it. That means the DE is parallel to the third side, which means B and C is parallel to B and C. Then is off of it. I mean DE is equal to of BC. That's all. Very simple. Okay, sometimes they will ask you to prove that. Okay, in midpoint theorem they will ask you to prove that DE is parallel to BC and also DE is equal to half of BC. So in this, if they ask the question like this, then what we should do? So I will tell you the answer. It is very simple. So first we will draw the diagram here. So the triangle A and here B and C, the midpoints D and E. So first what they have given is D and E are the midpoint of A, B and AC. Okay, so they have given. So to prove, what we should prove? We should prove that DE is parallel to BC and also we want to prove that DE is equal to half of BC. So we have to prove that. So first we should do the construction here. Okay, what should be done? I mean the construction should done. Okay, so the construction is we want to extend the point E. Okay, so we want to just extend the point E like this and give the name F here. And also again we want to extend the E such that DE is equal to EF. Okay, we want to extend that DE should be equal to EF. Okay, so we should join the CF. Okay, it should be like this. Then here there will be the triangle will be formed here, right? Yes. So here the one triangle will be formed. So we should just write that extend point E such that DE is equal to EF. Like that we should extend it. Then we should join, if the DE is equal to should be equal to EF, then we should join the CF. Okay. In triangle ADE. Okay, in triangle ADE and triangle EFC. ADE and EFC. So here AE is equal to CF because the E is the midpoint. Okay. So then next, DE is equal to BC. EF. DE is equal to EF due to the construction. Okay, due to the construction, the DE is equal to EF. Triangle, again, there are two angles here, right? So, angle 1 and angle 2. I give the name like this, okay? Angle 1 and angle 2. These are equal due to the vertically opposite angles. So, I have mentioned here that angle 1 is equal to angle 2 due to vertically opposite angles. Okay. Then next, triangle ADE is congruent to triangle EFC. By what? By the SAS rule. You know that what is mean by SAS? I mean, you know, right, that where we should use the SAS rule. Okay, let me remind you again. We should use the SAS rule if two sides and the included angle of one triangle are equal to the two sides and the included angle of the other triangle. Okay. Okay, you may have a doubt that why we should use the congruent here. By using the congruent, we can say that AD is equal to CF by CPCT. You know that corresponding angles, I mean corresponding part of congruent triangle. Okay, you know that what is mean by CPCT. So by using the congruent, we can say that the AD is equal to CF, and also AD is equal to BD. Yes. Therefore, the BD is equal to CF. So next, angle A is equal to angle C by CPCT, and also angle A and angle C are alternative interior angles. Okay, angle C and A are alternative interior angles. Next, so by this we can say that AB is equal to, is parallel to CF, and DB is parallel to CF. Now you notice the triangle. So when you take the B, D and F, C, it is like a parallelogram, right? So we can write here that DBCF is a parallelogram If it is a parallelogram, then DF is parallel to BC and DE is parallel to BC. Right, so we proved it. Next we just have to prove that DE is equal to of BC. So here the next we have to prove. So we know that DB and CF is a parallelogram. The next we should done that DF is equal to BC because the parallelogram has a rule, right? So opposite sides of a parallelogram will be equal. Then DF will be equal to BC, right? So opposite sides of a parallelogram is equal. Just simple. So next here DE is equal to EF. That means that DF is equal to DE and DE plus EF. So we can this DE and EF are same. So we can write as 2DE, right? So 2DE is equal to BC. So that means we can simply prove that DE is equal to of BC. That's all. We proved that DE is parallel to BC and DE is equal to of BC.
Here the 8.9, 8.10 we already saw. Let me explain you again.
The line segment joining midpoints of two sides of a triangle is parallel to the third side. So that line segment joining midpoints of two sides of a triangle is also the parallel to the third side. And also they have in theorem 8.10 they told the line drawn through midpoint of one side of a triangle parallel to another side bisects the third side. So that's all. We completed the introduction of chapter 8. So let me teach you the exercise in next video. Thank you. And also please subscribe my channel.